Hi there, welcome to Caltex Academy. Today we're looking at limits, and the method we're using is indirect method. And in our previous video we look at direct method, where we just substitute directly the value in which x is tending to into our expression or the function. So there are some questions in limit where this direct method cannot work, so we can use other techniques to make sure that we solve out. And to make this one here clear, we need to look at some examples. And before you proceed ahead, you can also check the link of that video in the description of this video here, so that you also see what we have done in question number 1 and that was in video number 1. So without further ado, let's have a question. Assuming we have a question like this, where we have limit as x tends to -1, and we have an expression like x squared minus 3x minus 4, and this is divided by x plus 1. Now in this question, you can attempt to enter this expression into a calculator, replacing every value for x with -1. But specifically, let's pay attention to the denominator. We have seen that we have x plus 1 and our x is tending to -1. If we replace x with -1, the denominator will turn to 0. Now in mathematics, we are not allowed to divide any number with 0, because that will be giving you some math error. And for that case, we need to use other techniques like factorization, looking at the numerator, and then we go ahead and use that indirect way of solving these limits here, to the extent that we need to avoid this -1 neutralizing with the positive to have 0 at the denominator. So what do we need to do here? Let me get what we have in the numerator. This one is factorization, and in one of my videos I talk about factorization. Again, you can check at the description of this video to see the links to those videos that we talked about factorization, especially for this one, factorization of quadratic expression, just like this. Now here we have a constant 4, and we need to look at two numbers of 4, or factors of 4, that when we add should bring for us -3, then when we multiply should get for us exactly -4. What are those numbers? I think -4 and 1 are the factors. So we shall use to disorganize this. So we shall have here x square minus 4x plus x minus 4. Then we can factor out what is common. So I am going the long way here for somebody to understand maybe. So we have x as the common factor in the first pair, because we have two pairs here. So what is remaining here is x minus, if x is out, meaning 4 is also left here. Now this one is almost similar to the first pair, so it means we need to multiply this by 1. 1 times any number will remain the same, so we have here x minus 4. Then when we collect the coefficient to form one bracket, we shall have x from the first bracket and then +1 from the second bracket as the coefficient. Then this is identical, we can take one of them and we have here x minus 4. Now meaning we can rewrite this one in terms of this. So let's move on and we disintegrate the numerator to this form. So in our solution, we can now say the limits as x tends to -1 of x squared minus 3x minus 4 divided by x plus 4, and be rewritten as the limits as x tends to -1 of x plus 1 times x minus 4, then divide by x plus 1. Then we close this one, and we can see here that x plus 1 in the numerator is the same as x plus 1 for the denominator, meaning we can cancel this term and we'll be left only with limit as x tends to -1 of only x minus 4. So here we can make substitution. As we substitute x with -1, then we can remove this limit away. So we'll have here -1 minus 4. And they have the same sign, so we simply add them together. Then we have -5 as our answer. So this is how we handle indirectly when you have a limit that the denominator will vanish into 0. We can try factorization and you find yourself done. So let's move to the next board to also look at another example similar to this to strengthen our knowledge. So question B is also saying we need to find the value of limit as x tends to +2 of the expression is x square minus x minus 2 over x minus 2. So as before, we know this one is positive, and already here in this expression we have -2. So if we substitute directly here, you realize that we can have also our 0. Now here we're limited, we need to look at also another method. Let's take the numerator, and that is x square minus x minus 2. And here the constant is 2. The two numbers here should be 2 and 1 as the factors that when we add together, it will bring for us -1, and then when we multiply, it will bring for us positive. So these are the factors that can bring for us this, and the short form is we just simply have x, then we have another x here. So here we just bring -2, then we have here +1. Now we can go ahead and work out this limit by having it as limit when x tends to 2 of this given expression x square minus x minus 2 all over x minus 2. This is the same as limit as our x tends to 2 of, now we're going to split this numerator into our x minus 2 times x plus 1 all over the denominator was x minus 2. Then when you check the numerator and denominator, we have something common again, that is x minus 2 and x minus 2. That will cancel out and shall be left here with limit as x tends to +2, the remaining term, and our term here is x plus 1. Take note that the word limit will go out in the process of substitution. If you don't substitute, please continue writing it here. That is one tip you need to mark. Now here, since we already got something simple, just like what we discussed in video number 1, then we can go ahead and work it out. We can replace 2 in place of x. So we have here 2 plus 1, which forms 3. Simple as that. So I've looked at 2 examples of using factorization of these normal quadratic expressions. Let's move on to the next board to see use of differences of 2 squares also here in this limit. So in question C, we also have a question here that says we need to evaluate limit as x tends to, again, 2, and here the expression is, we have x squared minus 4 divided by x minus 2. So when we look at this again technically, we realize that x minus 4 can be written as x squared minus 2 squared. So this becomes a difference of 2 squared, in that if you have x squared minus b squared, this can be written as the sum of the two terms a and b term is the difference of the two terms a minus b. So when we position our x square under a square and we give 2 square under b, we realize that the value for a will correspond to x and the value of b will correspond to 2. Now if that is the case, we can substitute. Then instead of a, we are putting here x, plus instead of b, we are putting here 2. Then we multiply by x minus 2. Now that is how we expanded the first one here, x minus 4. And the reason why we have done that, we have seen that here is 2 and we have negative 2, meaning if we also place 2 directly, we shall get 0 here, which is not allowed. So let's move on and get our solution done here. So we have our limit as x tends to positive 2 of x square minus 4 over x minus 2. So this is equals to replacing the numerator, so we still write our limit here as x tends to 2 of, in the numerator we have x plus 2 times x minus 2 all over the denominator x minus 2. We close our square bracket. So we can see again here that the second term x minus 2 is similar to x minus 2 from the denominator. So when they cancels out, then the remaining terms from our numerator would be the limit of x tending to 2 as x plus 2. So we can go ahead and make our substitution of x with 2. We'll have here 2 plus the 2, which is this one, making 4. And that is the solution using difference of 2 squares. Again, lastly, let's go to the last number to look at trinomial, where we have something to raise power 3 in the next board. So in part D, we have limit as x tends to 3 of x cubed minus 27 all over x minus 3. Now, before we proceed with the solution here, please, if you have not subscribed to the channel, please spare 3 seconds to subscribe to the channel, share this video with friends, and then like this video so that we push it to many people, and that will also encourage me or motivate me to make more videos of this kind. So let's move on. Let's try substituting 3 into x from the numerator and x from the denominator. So definitely, of course, we know when you put x here, you'll have 3 cubed is 27 minus 27 will be 0. Then our denominator we shall have 3 minus 3. This 0 at denominator is normal, but for the denominator is not allowed. So for that case, we also go ahead and take a look at a different approach. So let's move on here, and we take out our x cubed minus 27. This can be written the same as x cubed. Then we can rewrite 27 as a cube also. So 27 is the same as 3 cubed. Now let's go into this formula, which says if you have a value like x cubed minus b cubed, this one can be the same as a minus b times a squared plus ab plus b squared. So putting in here, just like how we did it in difference of 2 square, we have here x cubed minus 3 cubed. So wherever we get a, we replace it with x. So we have here x minus, whenever we get b, we replace it with 3. So 3 is going to replace b, meanwhile x is replacing a. So let's continue. We have here 3, then we'll close the first bracket, and then the second bracket is x square plus a is also x, and I'm multiplying this one here by b, which is 3, then plus b, and that is square, 3 square. So let's further simplify the second bracket, and then the first term here is x square plus x times 3, we can write as 3x, and then 3 square is 9, and take note that the second bracket we cannot tamper with it simply because we have got something similar to what we have at the denominator here. So at this point, meaning x cubed minus 27 can be written in this form here. So let's move on to replace that from our solution at this side. So we have limit as x tends to positive 3 of x cubed minus 27 divided by x minus 3. This should be equivalent to limit as x tends to our 3 of, now we are writing the numerator in a style, and we have here x minus 3 times x squared plus 3x plus 9. Then the denominator comes in, and that is x minus 3. Then we close our last bracket. So we can also see from here that these numbers, the first bracket will cancel with the denominator, and finally would rewrite this as the limit of as x tends to 3 of this remaining bracket, and our bracket is having terms like x square plus 3x plus 9, and then we can go ahead and make substitution where there is x, we place it there 3. So we have 3 square for the first term, and for the second term we have 3 times also 3 plus 9. Now when you square the first term, you get 9. If you multiply 3 times 3, we get 9. Then when you multiply, okay, when you add this 9, you'll have 27. this is our answer. So if I've watched up this time, thank you very much for watching, and please stay tuned to the channel because we're going to have video number 3 of the same limits, where we'll advance it a little bit. We need to look at some other approaches, like if we have a number with in the numerator something like maybe like this, and have denominator maybe something like that, how do you tackle this? That's going to be in video number 3 of limits. So please stay tuned and see you in the other one. Peace out.